Y equals, it's the simplest equation you can have with it still being a quadratic. It is y equals x squared, FYI. Okay, all right. So, ladies and gentlemen, let's go ahead and begin our learning objective. Pretty much sweet and to the point. We will learn stuff. We will learn to solve quadratics by graphing. And I'm going to throw in there and using the calculator. Okay, so just to let you know, today is a calculator intensive day. Make sure you're following along. Okay, you're taking good notes. Our first vocabulary term, we're talking about double roots, okay? It's basically, as was mentioned just prior right now, when you have a parabola, okay, you could have the situation where it touches the x-intercept 2 times, right? This is an example of a double root, okay? It is the roots of a quadratic function that are the same number. Okay. We'll pretend those are 2 words. Hold on, I can do better. So this really should be my counter example here, because are these at the same number? No, they're not. So this is my counter example. Oops. This is what it isn't. What it is this. Where you got a coordinate pair, right? And then you're going to put that parabola so that it just touches once. Okay. So that's where it would be that the roots basically both land on the same point, okay? So let's talk a little bit about roots. It's been a little bit, but do y'all remember ever talking about rocks? It's been a while. This was back in the linear, right? And I said there's 4 words that basically mean all the same thing. And on your star in 2 weeks, they will expect that you know this. R is for roots. X is for x-intercepts. Okay. S is for solutions. And 0 is for, O is for 0. Zeros. Okay, roots, zeros, x-intercepts, and solutions. Okay, all of these words mean the exact same thing. They expect, if they say, here's a quadratic, what are the roots? They expect that you know that that means the x-intercepts. If they say, please solve this quadratic, they expect that you know that that means the x-intercepts. And if they ask what the zeros are, same thing, okay? There are a couple of situations that we talked about. So let me kind of just point this out. Of course, we have our x-intercept there. And while I'm discussing this, what do you remember about x-intercepts? Do you remember something? What is special and unique about x-intercepts? Do you remember? Put it in the chat if you don't know, if you don't want to say it out loud. And I'm going to give you one scenario here, like our double root that we talked about. There's our parabola. Here's like our counter example right here, right? And here's another scenario. Okay. All right. What you need to know about x-intercepts, very, very critical, is that y will always equal to 0 at the x-intercept. What's equal to 0 at a y-intercept? Yay, good job. So what I'm going to draw here, I'm going to draw the solutions. This is a scenario where we have one solution available. Okay, right here, how many solutions do we have? How many x-intercepts? How many roots? How many zeros? 2, 1, and 2. 2 solutions. All right, and then here, how many solutions do I have? 0 solutions, no solutions. It does not touch the x-axis ever. Okay? All right, any questions? So let's talk about example number 1. Before I can start to solve, what must be true about my quadratic? It has to be equal to 0. Good. Okay. Has to be equal to 0. If that's not the case, you better make it happen. Okay. That must happen. Okay. So I'm going to put it here. To solve, must be equal to 0. Okay. Keep that in mind. All right. So the first thing we're going to do, I'm going to show you one way so that you can identify from a table and from just an equation. We're going to start with this. Now that I have it equal to 0, I'm going to plug this in, okay? And I plug it in by going to y equals in my calculator. And please follow along because it helps, okay? You have x, you have squared, right? And then minus 3x and minus 10. I'm going to go ahead and pull up my table. So see how table's in blue? So I want to hit the blue button first, second, and table. Anybody need to see that again or you're okay? See it again? Okay. So here I am. Okay, I'm going to clear all this stuff out. And we go to, I'm going to type it in, x squared minus 3x. Start from the very beginning. Okay, I can do that. Minus 10. Okay. So let me start from the very, very beginning. I'm going to wipe my whole thing clean here. Second plus 712. Oh, that's not what I wanted. Second plus. So I'm wiping my whole calculator clean, right? I'm here at this screen, right? How do I get to the point where I can enter an equation? Y equals. So I'm going to write that down as my first little button. Okay, this is how we enter an equation. Y equals. Okay. Now X is the button right next to alpha, right? So X, and then I have a X squared button here, diagonal from 7, and then minus 3x minus 10. Better? Okay. Now to get the table, so this was to enter the equation, right? So here, enter equation. That's what we did for that. And now I want to look at a table to get access to a table. So for a table, I need to select what 2 buttons? Second what? Second graph. Second and graph. Okay, so I'm going to go ahead and do that. Second graph. Yours says error. I would bet if yours says error, look and see, did you ever use the negative? No? Okay, that's one really common error. If you use the negative instead of the minus, it will give you an error. Why don't you bring it up here real quick? And I'm going to go ahead and keep going. Okay, bring your whole thing up. Second table. And I want to include some negative values, so I'm going to go right up here. I'm going to start off here, and I'm going to write down my table. Okay, guys? So hold on one second. Let me pause this real quick. Alrighty, so let's look at this table because there's a couple interesting things. One of the things I want to point out is that I'm going all the way from -3 to 6, okay? And I'm going from like -12 up to 8. So obviously if I don't change this and like, if I make it go up by 1, it's not going to cover it, right? Let's look at the y's. In order to make it go down to -12, Emma, how much am I going to make each one of these little ticks worth in order to make sure that I can get to -12? Yay, better, yes? Yeah. Okay, cool. Emma, are you there? She says you can go down by 3. Yeah. So if we do -3 -6, -9, and -12, we get there, right? And we can kind of go up by 3s here too. Okay, that's a good idea. And also now in order on the x-axis, my biggest number is 6, and I have 4. So how much would I need to increase that by, Ezra? Each one would have to be worth what in order to at least cover 6? And Jack would like to help if you would like a hand. If you think you know it, go for it. Okay, Jack, you want to help him out?
No, by 2.
If I go up by 2, I should be good, right? 2, 4, 6, 8. That'll cover it, right? That'll get me big enough. All right, cool. So let me talk to Fabian. What point on here looks interesting, like, or you think is significant for some reason, or has an interesting pattern to it? 0, -10. Now, why? Why do you think? Because I agree. I think that that's a good, interesting point. What is that point called? That is the y-intercept. But it hits the y-axis, right? And so I'm going to go ahead and plot that. And as we discussed last time, that's actually right here. I got 0, -10. So it's going to be about right here. Yes, about right there. And sure enough, it's our C value on our equation. Like last time we said C was always the y-intercept. So good. I think that's an interesting point too. Faith, any other interesting points on this table? Five and 0? Yep. Along with what other one that has something in, like these two right here, right? Do you know what those are called, ma'am? This one was a y-intercept because x was equal to 0. So these are the x-intercepts, okay? And do you know what are 3 other names for the x-intercepts? So as I plot these, I'm going to go ahead and plot them. And I've got -2, 0, and then I've got 5, 0, okay? So Gino, do you remember what the other names were for x-intercepts? No? You need a hint?
Yeah.
Actually, I was talking to you, Gino.
Yes.
Okay, you need a hint? All right, here's your hint. Rocks. So if these are x-intercepts, what are the other names? Do you know one of them? What did you say? I'm sorry?
Solution.
Solution. I love it. That's very good. Okay. And the others, does anybody know? R is for? Yes. Roots. All right. And of course, this O here is for 0. Very good. Okay. Be prepared. They will ask for any of these. Okay. So we're looking at roots, zeros, x-intercepts, and solutions. So those are some interesting points. And honestly, if they say solve, at this point, you could stop, right? You could stop and say, I'm looking at it on the table right here, right? I'm looking at -2 and 5, and I'm done, right? You could also write it like this: x is equal to -2 and x is equal to 5 as my solutions. Or you could have the actual points of -2, 0 and 5, 0, right? A couple of different ways you could write the same thing, okay? Now, if I plot this, I think these 2 points are kind of interesting. What do these tell us? What are those? What would you call that? This whole idea. I got 2 -12s. I got 2 -7s. What do we call that? Starts with an S. Yes, Jack. That's the bottom curve part, right? Because if I plot that, that's like 1 -12, right? And then I've got like 2 -12, right? I got 2 points right here. And then this was 0, -10. So over here, I've kind of got the same, right? I got a -6 at, let's see, -6 is at -1. And then it's also kind of like right here. What do we call that? Starts with an S. Let me see, anybody online knows this. Let me talk to Jessica. Do you know? Do you need a hint? It was the last time we talked about it. It's something that you see in parabolas. As I draw my little line here. So I'm going to connect all the dots. Parabolas have this, and it starts with an S. Nobody remembers? It is called symmetry, y'all. Symmetry. Okay, remember I talked about your face, right? For the most part, you got like one eyeball, right? If you draw a line right down the middle, one ear, one ear. So there's this concept, right? And from here, I could just kind of like, if I know one point on one side, I can definitely just make an assumption about it, right? And our axis of symmetry usually goes right in between. Yes? Okay, so make sure you know all about axis of symmetry, your vertex, how to calculate it, all of that good stuff. Any questions so far? All right, so this is how you can tell just by looking at a table, or if you were given an equation, what the solutions are. Okay, now I'm going to go to a more calculator intensive method. And so scribble down some notes, guys. We got calculator method. Did I unpause that? Please tell me I did. Yay, okay, good. So pause method. All right, so number one, we're going to put in our equation, y1, right? And it has to be equal to 0. Remember that whole equal to 0 thing, right? So that's important. Number two, we have to graph it. Hit the graph button. And number three, you're going to do something called second trace. Okay, these are buttons. And then you want to select 2 for 0, for the 0 option. Okay. Hopefully this will make more sense in a little bit. So let me talk to Jude. What do I have to do to this equation, sir, before I can start punching it in the calculator? Let me know if you need a hint. And we are recording.
Yeah, I really don't know.
Okay, it has to be equal to 0. Is it equal to 0?
No.
No. What do we do to make it equal to 0? You additive inverse, which of course is plus 16 plus 16. Can I add 16 to 8x? No, because they are not like terms. So I'm going to go ahead and I'm going to rewrite my equation to be x squared plus 8x plus 16. That is a plus. I should probably make that better. And now it is entirely equal to 0 and we can proceed. Yes? Okay. So I'm going to go ahead, type that in. I go to y equals, right? I can clear out this whole thing. X is located right next to alpha, right? X, and then the little squared. Plus 8x plus 16. And does it look the way I want it to look? Yes. Did I put equal 0 on there? No. So now I'm going to select graph, number 2. Okay. How many solutions am I expecting, boys and girls? One solution, okay? Based on this table, second table, let me look. Where should I expect my solution to be? What should I expect my solution to be just based on this table? -4. Y'all see that 0 right there, -4? I'm going to go ahead and just really quickly sketch this. This is like what? I'm going to make it like each one worth 2. 2, 4. So I've got 0, -4. That's like a point right here, right? And then I have another point, 1. So -5, 1. -3, 1. Because of symmetry, I can just kind of do that. And I'm just going to sketch it real quick. Okay. But here's another way other than looking at the table, because sometimes it's not always an integer, right? So I can go to the graph. And we're going to start with second trace. Okay. Second trace. And I want to go down, and I see 0 right there. So I want to select 2. Now, when I'm looking for where it touches, right? And it says left bound. So we're like telling the calculator where to look, right? And so there's going to be this little spider. Let me show you where he is. Let's see if I can find him. There he is. He's coming down. And I want him to move to the left of the pink dot. Now, he could be there, or he could be all the way up here. It doesn't really matter. I'm just saying, hey, start looking here, okay? So I'm going to click enter. Then I'm going to go to the right of the pink dot. And again, it doesn't matter if I'm here or here, as long as I'm to the right of the point I want it to find. And then I hit enter. And then it says guess, no thank you, I'd like to know. And that's my actual answer. Negative, we can round it, -4, 0. Yes? It's exactly what was in the table. So we have a solution of -4, 0, otherwise known as x is equal to -4, otherwise known as a solution set of -4. Questions? All right. Yes. Say it again.
Are we always supposed to round up?
This one, because it is -3.9999, okay, 9999 is a good indicator. It's pretty close, right? And if I was rounding to the nearest whole number, 5 or more, raise the score. Yes? Okay. So then you would just add, we get that. Yes, ma'am.
How did you get like the dot in the X?
How did I get the dot, that pink dot?
Yeah.
I drew it.
Okay, and
Yes, ma'am.
how did you get the point?
How did I get the point?
How you got it was 4.
To know that it was 4? Okay, so like the calculator part? Okay, so let me show you again, okay? Let me go ahead and I'm going to pause this. All right, so ladies and gentlemen, example number 3. Go ahead with this one. I'm going to go ahead here. I'm going to be a little lazy. I'm going to go right on top of my old numbers, and I'm just going to put a 2. And then I'm going to have delete and then put a 3 and just make it look like that. Because it's already set equal to 0, so that's perfect, right? Okay. And Juliana, what do I need to do now? What do I need to do to get my solution? What could I do? Give me an idea. We've had it a couple ways.
Like in the calculator or
Yeah, in the calculator, yes, ma'am.
graph?
Graph, we could do a graph, okay. And when I look at that graph, how many solutions am I expecting?
1.
Okay, remember solutions are also x-intercepts, yes? Yes, so it never touches that x-axis, right? Therefore, no touch, no solution. Okay, so if it doesn't touch that x-axis, there is no solution. And by the way, every once in a while you might see something like this. That actually means null set, okay? It's something that's like a set with nothing in it. There is nothing that will make this equation true. I'm going to go ahead and just sketch it just a little bit. I'm going to look at second table, and I'm going to go to where the small numbers live. I see some smaller numbers over here. So I got like a vertex at -1, down 2, and I've got like a 0, 3. And because of symmetry, I know I probably got another dot right there. Oh, 0, 3, my bad, like this. Let me erase that. I can count. And then I have something kind of like so, right? Does that match what we were looking at?
No.
Am I plotting these points correctly? Like, I don't think so. 0, 3, 0. What am I thinking? Oh my God, y'all, sorry. Well, here we go. Y'all feel free to correct me when I do stupid stuff. All right, 0, 3, like this. 1, 6. Okay, that's too high. -1, 2, better. And then there we are. I can assume this. Yes. Does that feel better?
Yeah.
It does to me. Okay, great. So there we are. Okay, Monday morning, wake up. And yay, no touch, no solution, but that still is true. Yes? All right, ladies and gentlemen, I want y'all to go ahead and try number 5, please. Okay, try number 5. I'll give you about a minute head start. Go ahead and do that. I'll let pause. And so here we're just going to type in the equation, -4, and then I got +2, right? Now I'm going to graph. How many solutions am I expecting? 2, because it hits the x-axis 2 times, right? So, and it's really important that you could see the intersection, guys, okay? If you can't see it, then you need to play around with zoom. And there's 2 options I like. There's zooming in and out, right? If you do zoom out, you need to hit 3 and then enter, okay? If you do zoom in, you got to hit 2 and enter. Or the other option is that you can go up to zoom 0, and this is called zoom fit, and it's supposed to just fit it in there, right? Which it sometimes works and sometimes doesn't. But as long as you can see the intersection, you're good, okay? Now we're going to go in here and select second, trace, 2. Now I have 2 points here, right? So I have my pink point, that's one solution, and I have yet another one, I'll make it blue, over here. So what I'm going to do is I'm going to tell the mouse, yep, here, the spider, you're to the left, great, hit enter. And then I want you to go to the right of the pink dot. I'm going to stop right there. So I'm saying, look between these 2 points and hit enter, and then enter again. And so that point looks something like this, where I have, where I have something like x is equal to something awful here, 5, 8, 5, 7, 8, 6, 4, 4, right? And I'm going to have another solution over here. I'm going to go ahead and figure out that one. So that's going to be second trace 0. And I'm going to go over to the right. I wanted the left. So I start right there. And then I move to the right of the blue dot, because I would say look between here and here for the blue dot. Enter. Yes, no, thank you. And now I have another solution, right? 3.4142136. But they told us to round to the nearest tenth. How many places after the decimal is the nearest tenth? 1. Good, because 10 has 1 0. So I want to go 1 place after right there, right? Now the rule is, of course, 4 or less, let it rest. 3.14. 5 or more, raise the score, add it to 0.6. So this is one solution, and this is another solution, aka 0.6, 3.4. Questions? Now, if you went all the way to the left here and all the way to the right there, it was going to give you an answer, but it was only going to give you one of the answers, right? So do you see how to get the answer you're looking for specifically? Okay. All right. Any questions? Let's go ahead. We're pushing through. I know it's a lot of information, guys. Yes. Yes, sir.
So for mine, I've checked the equation twice now, but my graph doesn't have the same points as yours.
Okay.
Like when I go to the line for the first one that goes to x.
Let's compare our equations really quick. Okay. Go to y equals. Do you have x squared with a minus?
Minus 4x plus 2.
And it's not a negative.
It's not a negative.
It's not a negative. Okay.
X squared minus 4x plus 2.
Okay.
You have 0.584. I have like 0.4.
Oh, you're talking about as far as the decimals go. Yes. Okay, and it's like all the way over in here, like 0.5, and you have 0.4.
Yeah.
Okay. I'm gonna have to look at that. Let me look at that right after we get done with the whole thing. Okay.
Okay.
All right. Let me go ahead here and continue on. We're gonna go to number 4. We're gonna go back up to number 4. Okay. So with example 4, we're given the quadratic function, and we're given the graph, and we need to find out what the function is, okay? For those of you who have been with me all year long, this may ring a bell as far as regression, okay? This is basically called quadratic regression, and we've done linear regression, okay? But we haven't done quadratic regression, and there's a whole click sheet that's underneath your calculator folder with all the full instructions. But here for quadratic regression, our calculator method, here's the simple version, is that you're going to put in, you got y equals, right? You want to put in your equation, enter equation. Okay. Then you're going to have, let's see. No, we don't have our equation. I'm so sorry, my eyeballs are skipping. Okay, so that's for the other one. We basically it's this stat, erase that. Stat, calc, and 5. So sorry, my eyeballs were skipping spots on my notes. Stat, calc, and 5. And I'll show you how to do that. That's basically a big note, okay? So let's go ahead and pull, like, you have to have at least 3 points, okay? So you must at least 3 points. Okay. I'm going to make a little table. And I'm looking at my first point, -1, 0. Does that look right? Let me know if I'm wrong. And 0, 2. And 1, 0. Okay. So just like when we did the regression, and especially, I guarantee they're going to have one question on your STAR in 2 weeks on like scatter plots. More than likely, there will probably be a couple on like with regression. If you don't remember, if you're like at the beginning of your calculator sequence right here, right? You had second mode, you're in the very first screen. What you do is you need to go to mode and turn on your stat diagnostics. So go to the right and hit enter and turn on your stat diagnostics. This, of course, is for your correlation coefficient to tell how strong an argument was. If you have a strong but, negative and like, do you remember what scatter plots, the dots? If you don't, make sure you go back to that lesson, okay, and study that. But stat diagnostics gives you the correlation coefficient. So once you have that, you don't have to do that again. It's just the one time. So now from this screen, I'm going to select stat. I'm going to select 1 for edit. Okay. So maybe I'll make that note here. Stat. Okay, I can do better. Stat and 1, right, for edit. And this is basically how you enter your table.
Wait, so how do I get to stat diagnostic?
Mode. And then go down.
So wait, I tried to, so the stat calc 5 is
Okay, hold on one second. So in here, stat 1, L1 is where all your X values will go. -1, enter. 0, enter. 1, enter. You're going to go to the right and put in all your Y values. 0, enter. 2, enter. 0, enter. And you should have a table that looks like your own, right? Now that you've entered your table, now's when you select stat calc 5. So again, that is stat, to the right, calc, and 5. And you're going to hit enter 3 times. Okay? And you end up with this. So I'm going to put enter 3 times. Okay? So what you get is y is equal to, and instead of a, you put in the -2, and you got your x squared, plus 0, we get the 0 from the b, right? And then plus 2. And your correlation coefficient right here, this is 1, means your dots are right on it, okay? If you are looking at this equation, let me talk to Chloe. What term do I not need in my final answer? Yes, ma'am. So this 0 times x, that becomes 0. It just kind of goes out the, out the door. And so we end up with y is equal to -2x squared plus 2. And there you go. It's your final answer. Questions? Okay. All right. Last one. We'll get through this. Example number 6. Consuela built a model rocket for her science project. The equation is here. And please note that that is supposed to be a little 2, okay? Plus 250 T models the flight of the rocket launched from a ground level at a velocity of 250 feet per second, where h is the height of the rocket in feet, okay? H is where the position where y normally is, so this is height in feet. Okay. And after t seconds, t is in the position of x, so we know that this is really t, and we're talking about seconds. Okay. Make that nicer. Now, based on what we learned in the last section, what is my y-intercept going to be for this particular quadratic? What is my value for C? It's not there, right?
Yeah, no, well, you know, it's something.
It's not there. So what is the value if it's not there? 0. So I know that I'm going to start off at 0. That's my y-intercept, the origin, okay? And basically it's got a negative sign right here, right? So that means it's going to make like a sad face and go something like that, right? Boom. Yes? So I don't know exactly what, but that's essentially what the rocket's going to do. And it's asking how long was Consuelo's rocket in the air? So what are we in search of? H or T? T for time, right? Good. So how long tells us, hey, what is the time? Okay, so we're going to solve for T. Now, when we put this in our calculator, number 1, we don't use T, we're going to use X. Number 2, it still has to be set equal to 0. So let's figure this out. H is going to be equal to what? When it hits the ground, it's this right here, right? Tell me about this point. We may not know how long it took the T, right? But we do know its Y value. What is the Y value? 0. So guess what? That's your H. That's your Y, right? So I'm going to replace that H with a 0 because the height is at 0 out on the Earth. We have negative 16t squared plus 250t. So I'm going to plug this into my calculator, clear out what's there, and I've got negative 16x squared plus 250x. Okay? And I'm going to go to my graph. And I don't even see it because it's so big that I can't even see it. So I'm going to hit zoom. Zoom 3 to zoom out. 3, but remember you have to hit enter. And I see it, but it looks terrible, right? It's like I see part of it. Let me see if I can zoom fit. Zoom. I'm going to go to 0. Okay. Enter. And I see something like that. Let me zoom out one more time because you have to see the intersection. I'm going to do my steps. Second, trace, 2. To the left, enter. To the right, all the way to the right, enter. Guess? No. And I'm given a solution of 15.625, 0. And I know it started at the origin, so this has to be the second solution, right? And we're looking at Consuelo's rocket was in the air for about 50, let's just make it 15.6 seconds. Y'all have a beautiful day. Take care.
That's the best I can get.